This is Calculus 2. This video, we're going to talk about washer method. Previous video, we did disk method. You guys have understand difference between disk method, washer method. Let's start this washer method. What is a bit different from disk method? Here is, look at this graph. Disk method, we rotated, guys, remember previous video, we rotated rectangle. This one is, they have a hole is right there, guys. This is a hole. This one, disk method, there is no hole to the axis revolution. So when you rotate this rectangle, you make a disk. There is no hole, this 3D object. But this one, here is a hole, guys. When you rotate it, you make this object in 3D, which means this looks like donuts. Now, what you're gonna do, this one is donuts. So let's find this volume of this 3D object. So how can find this volume? Looks like volume of the big disk, volume of subtract volume of a small disk, okay? So volume gonna be, big disk is pi. The radius big disk r square, height gonna be w, minus, you have subtract inside hole, inside the disk. So this is a hole, you subtract hole gonna be pi r square w. So this volume for this shape object, that's gonna be pi r square minus r square w. So how to understand this one, guys? Here is radius of big disk. This one is radius of small disk. Then this formula is radius square minus r square. So very carefully, this one is not same pi r minus r square w. So this one is not same. Make sure you understand this one, guys. How are we gonna find the volume by using the washer method? Here is gonna be, guys, look at this one. This region is blue one, this one region. You're gonna rotate this axis, rotate this one. Then you're gonna make this 3D object. So we wanna find the volume. So like a disk method, we're gonna make rectangle right there is perpendicular, but this rectangle is have a hole on to the axis of revolution. This is a hole. That's why we're gonna using washer method, guys. Clearly see you have to using washer method because there is a hole right there, guys. Okay. Now how gonna find this 3D volume right here? So we did find area or a volume with this hole. So excuse me. Thinking about pi is gonna be always there. This one is longer radius square minus this one is shorter radius. That's you're gonna find the volume by using the washer method. So here is, you have to remember about the washer and disk method. The washer method, there is a hole. Disk method, there is no hole. So that's how to see the question when you do your problem with volume. Let's start with the first question is right there, guys. Look at this one. We're gonna find the volume which is generated by this region. Look at this one. This one is we are looking for a volume generated by this region. So I'm gonna erase this part right there. Then you guys, the make a rectangle is right here perpendicular to the axis of revolution right there. So this case, guys, look at this. Make this 3D shape. Then this shape, here is a hole in this disk. So we cannot use this method. Definitely we are gonna use washer method. That's down. This one is rotated x-axis. This volume gonna be pi integral. This depth's gonna be dx. So you're gonna have dx. You're gonna find the interval of x. Here is 0. Here is 1. So 0 and 1. That's you write down for washer method. Now, what you have to here, because you recognize a hole, first you're gonna find the longer radius. Longer radius from here to here, that's the longer radius is r. Here to here, that's the y. So y, that's the radius is longer one. So y equal x, that's the x squared minus. What is the shorter radius here, guys? Shorter radius gonna be right here. This is right here. That function. That's the y equal x squared, parentheses, radius is x squared, that's square. Let's just set up this integration. So pi integral 0 and 1, x squared minus x fourth dx. You're going to find the antiderivative of pi gonna be 0 and 1. Not 0 and 1, right? Pi antiderivative x cubed over 3 minus x fifth over 5, 0 and 1, you're going to find this volume. 1 over 3 minus 1 over 5, that's going to be pi. Common denominator 15, 5 minus 3, that's going to be pi 2 over 15. So answer gonna be 2 pi over 15. That's the volume of this 3D. Let's do another example for washer method. Here is washer method. Here is top is y equals square root to x. Bottom is y equals x squared. You have region. I'm gonna rotate this region over x-axis. So we're gonna make rectangle perpendicular to the rotating axis. Let's make it. Can you see the hole is right there? This is a hole, guys. This is a hole. So we're gonna using washer method. Washer method gonna be volume gonna be pi. This is rotating x-axis gonna be, that's gonna be dx. So integral, you're gonna write down integral 0 and 1, 0 and 1, longer radius square and shorter radius square. That's you write down here. So longer radius gonna be here to here. That's gonna be y square root x. So y gonna be square root x squared. Shorter radius gonna be right here. This is y equal x squared, x squared. That's you write it. So now we have evaluate this one equal pi integral 0 and 1, right? 0 and 1 square root x square is x squared power x fourth dx right here. Find the antiderivative x squared over 2, x fifth over 5, where 0 and 1. This is the pi, 1.5 minus 1 over 5. This is gonna be pi. Common denominator 10, 5 minus 2. That's we have 3 pi over 10. That's how to evaluate this washer method. So another example, we're gonna using washer method, but this example a little different from previous example. So far, we use x-axis, y-axis for the rotating axis. But this example say we're gonna find the volume formed by revolving the region bounded R by the curve of y equal x squared, y equal x about y equal 2. That's the difference, guys. Y equal to. So we're gonna use y equal to right here. So where to where? Here is gonna be here. So y equal to is a horizontal line is parallel to the x-axis. So we're gonna rotating here right there, guys, okay? So this one is first we're gonna sketch the rectangle perpendicular this rotating axis, but here is a hole. So we're gonna use washer method, right? Because here is a hole. Here is a hole. So what you have to do with the washer method, you're gonna write down the volume of washer method. You're gonna do the pi integral. This is a horizontal line parallel to the x-axis. You're gonna put the dx. So write down interval of x, 0 and 1, 0 and 1. Now, inside the washer method, you're gonna do longer radius square, r square, minus shorter radius square. That's the washer method. So here is the picture about the longer radius. Longer radius gonna be, guys, here is the rotating axis. Longer radius is here. So look at this one. I just expanded. Here is a graph right here. This is longer radius. So how can find this one? From the here to here in the x-axis, that's the 2. Here to here, that's this graph. That's gonna be x squared. That's x squared. So longer radius are gonna be 2 minus x squared. That you find first, guys, okay? So you find it. So smaller radius are, from the here, smaller radius gonna be, this one is a smaller radius r. So this one is gonna be, this graph is gonna be y equal x. Here is a smaller radius r. Right here to here, that's the x. That's gonna be, this one is x. So these are gonna be 2 minus x. So smaller one is a 2 minus x. So what do you find this one, guys? Look at this one. Here, pi integral 0 and 1, 2 minus x squared minus 2 minus x squared. Oh, I missed the square, right? Radius square minus radius square dx. So now when you have this one, you have to simplify. Algebra is very careful. Expand this one, 4 minus 4x squared plus x fourths. Minus, expand 2 minus x squared. That's the 4 minus 4x plus x squared dx. Make sure algebra, when you distribute to negative, 4 minus 4x squared plus x fourths minus 4 minus minus plus 4x minus x squared dx. Here is a pi integral 0 and 1 x fourth power. 4x squared negative 4x squared make 5x squared, 4x, and cancel out 4 and negative 5 dx. So when you see it, now let's find the antiderivative, the function. So what do you have here? Pi x fourth fifth power over 5, 5x cubed over 3, 2x squared, 0 and 1, pi 1 over 5, 5 over 3, plus 2. You're going to find the common denominator. That's going to be 15. 3 minus 25 is 30. So you have 3 minus 25 is 30. 8, 5 over 15. This equation is not easy, guys. Find the longer radius, smaller radius, then find a washer method. Then you're going to find capital R, lowercase r. Let's do another practice problem by using disk method, washer method. This one is you don't have to evaluate the integration, just to set up the integral for the volume of the solid. You're gonna use this method or motion method depends on the rotating axis. Let's start with, guys, start with rotating over x-axis, rotating over y-axis. First is just this function is y equals square root of x. You're gonna do 0 and 3. First one is rotating over x-axis. So you're gonna draw the rectangle perpendicular to the x-axis. That's the here rectangle. So this one is going to be no hole at all. This one is disk method. This method going to be v equal pi integral radius square d rotating x at dx. Okay. What is it? The interval of x going to be 0 and 3. So 0 and 3. R is, this is R. This is y value, y equals square root x. This is square root x. Pi integral 0 and 3 x dx. That's you're going to find volume rotated the region over x-axis. Now, second is we're going to rotate it y-axis. So y-axis. So we're going to draw the rectangle perpendicular to the y-axis. This is going to be this shape. Guys, right? So here is, can you see the hole here? This is a hole. So this one is washer method. Y-axis, parallel y-axis, so we're gonna have volume pi integral y-axis, that's the dy, longer radius square, shorter radius square. That's the washer method, guys. Clearly understand that. So longer radius gonna be here to here. What is it? Radius gonna be 3. That's why you put the 3 square. Shorter radius gonna be, this is shorter radius. How can find this? This one is x value. So we're gonna find the x from here. This one is y equals square root to x. So x gonna be y square. So radius small one is y square. So simplify this one. Pi integral 9 minus y fourth. I missed the boundary, right? dy. Y is gonna be, here is 0 to the where? Right here. You're gonna find this y value. What is x value? 3. Plug in here. So y gonna be square root to 3. So 0 and square root to 3. 0 and square root to 3. That's how to find the volume rotated, generated by the region over y-axis. We're going to using same region bounded by y equals square root x, y equals 0, x equals 3, but we're going to rotate different line, not x-axis, not y-axis. We're going to use x equals 3 First one is x equals 3 right there, rotating x equals 3. That's parallel to y-axis, right? Parallel to y-axis. But you're gonna draw the rectangle perpendicular to the rotating axis. That's gonna be here. Let's say this one is gonna be disk method and washer method. Look at this rectangular to the perpendicular to the rotating axis. Can you see the any holes? No, which meaning is this one is disk method. Disk method gonna be pi integral. This is parallel to the y-axis. This gonna be dy. Then here is radius square. That's we're gonna do it. Guys, very carefully understand this one. So y value, interval of y gonna be, here is 1. So here is 3, I'm sorry, 3. You have y equals square root to x. So this y value is square root to 3. Here is dy, you're gonna write the interval of 0 and square root to 3. Big challenging part is you're gonna find the radius about this one, guys, this one. What is the radius? This red one here. Here is gonna be this is radius, this is rotating axis. So we know that this one, that's gonna be x. What is x? X, you find it. X gonna be y square. That's gonna be y square. We're gonna looking for this is radius. So here to here is whole thing gonna be 3. So radius gonna be 3 minus y square. That's you're gonna find here, guys, okay? So that's you're gonna do it. Guys, make sense? So last one is, here is we have example is rotating y equal -1. So you're gonna draw the line right here is here. So this line is y equal -1. This is parallel to the y-axis. Rotating this one is gonna be, which meaning is we're gonna draw the rectangle perpendicular to the y equal -1. That looks like this. So this is, you see, there is a hole right here. So this is washer method. So volume gonna be, this is parallel to the x-axis, pi integral. Here is dx. What is dx? 0 and 3. 0 and 3. So now what you have to find the radius, longer radius square minus shorter radius square. That's what we're gonna do it right here. So what is the longer radius? Find the longer radius, gonna be right here, guys. Here to here, that's the longer radius. Right here to here. I'm gonna using different color to make sure you guys understand correctly. Blue one is longer radius. First one is you thinking about here to here. That's gonna be 1. Here to here, that's y. That's square root to x. Longer radius, the whole thing gonna be 1 plus square root to x. That's the longer radius. Guys, make sense that one? And now we have the shorter radius. Shorter radius, here is right here. That's gonna be whole, empty space. That radius is 1, so 1 square. That's you're gonna find this volume by using the washer method. Guys, when you study volume by using the washer and disk method, big difference is when you rotate the rectangle, they have hole or space between the rectangle to the rotating axis. You're gonna decide this is gonna be disk method, this is washer method.